Okay, so let's take a look here at this problem. The integral from 1 to infinity of 1 over x squared dx. And so here we are looking at, oh shoot, I got the wrong graph for you. Just ignore that graph. I graphed the wrong function for you. I graphed 1 over x, not 1 over x squared. Okay, so there's my 1 over x squared graph. As we're approaching 1, from 1 to infinity, 1 over x squared. A little typo there, didn't put everything in, but there it is. So, to our problem, there's 1 over x squared. You can see it actually gets down pretty quickly. Here, I mean, this is a half, and it's getting down towards 0 pretty quickly. It'll never reach it, of course, but it's getting close to it really quickly. So, here's how we approach our problem. So, before we get into the integral and the overall techniques of it that I had already mentioned, let's create a function here now. I'm going to define the function capital A of b, area of b, is the integral from 1 to b of my function, x to the minus second dx. And well, using our integration techniques, this is a simple one. We just add 1 to the power, get minus 1 over x, evaluate it between 1 and b, simplifying, that would be negative 1 over b plus 1 when you evaluate that. Okay, so this is what the function looks like, negative 1 over b plus 1. And let's just start computing this for some different values and see what happens. If we plug in 2, we'd have negative 1 half plus 1 would be 1 half. If we plugged in 10, that would be negative 1 over 10 plus 1 would be 0.9 or 9/10. And finally, if we plugged in 100, we'd have negative 1 over 100 plus 1 would be 0.99 or 99 out of 100. So it certainly seems like this area is settling down to something. It certainly seems like this area is settling down to something. Okay, which seems like it's settling down to 1. To find out if it actually is, we're going to use our limit process. We're going to use our limit process. So this is how we would set the problem up. We would say the integral from 1 to infinity of 1 over x squared, or x to the minus second, dx, would be the limit as b approaches infinity of the integral from 1 to b. But again, I'm going to write that as x to the minus second dx. So this would be the limit as b approaches infinity of negative 1 over x, evaluated between 1 and b. Excuse me. Excuse me again. And so we evaluate. And again, this would be limit as b goes to infinity of negative 1 over b plus 1. All right, so we can take that limit then. Remember, if you have a fraction divided by a number, and that number goes to infinity, then that expression all just goes to 0. And so 1 is a constant, so the limit of 0 plus 1 is 1. So here we have an infinite integral where the area goes to 1. The area goes to 1. Okay? So therefore, we actually have a finite integral. We actually have a finite integral, even though it has an infinite width. It gets close enough, quick enough, that we actually can talk about that integral there. Okay, and it actually has a finite value. Let's contrast that with our second example. Let's do the integral from 1 to infinity of 1 over x dx. Well, again, we would say that that's the limit as b goes to infinity of the integral from 1 to b of 1 over x dx. That would be the limit as b goes to infinity of the ln of x, or sorry, the ln of x evaluated at 1 and at b. Ln of 1 is 0. So this would be the limit as b goes to infinity of the ln of b, which is equal to infinity, right? That we say diverges, doesn't approach a number, right? That's approaching positive infinity. How do I know that approaches positive infinity? Well, we go back and we do a little bit of calculus 1. How do I know that limit as b goes to infinity of ln of b actually goes to infinity? Well, we go back and do a little bit of calculus 1. If our function is the ln of x, ln is only defined for positive numbers. Its derivative, f prime, is 1 over x, which is greater than 0 anytime x is greater than 0. So the derivative of ln is always positive. If its derivative is always positive, that means that ln is always increasing. And since it's always increasing, if we let b to go to infinity, ln of b will go to infinity. And so this integral here actually diverges. So 1 over x squared approaches a finite amount, but 1 over x actually approaches infinity. And we can see this idea, a little bit of it graphically, I think. The difference between these two functions, you can see that the 1 over x squared gets close to 0 quick enough, whereas the 1 over x, turns out it doesn't get there quick enough. It's approaching 0, but it's not getting close quick enough. And that leaves for an area that will continue to grow, albeit very, 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 very slowly. But it will continue to grow, whereas the 1 over x squared one has closed the gap quick enough that we actually have a finite amount.